Hello, this is Adolf. Welcome to video lecture series on the course of building construction. In this video, under the topic of masonry materials, we are going to see about building stone. In this video, we are going to see about the introduction and what are the classification of rocks, what are the requirement of good building stone, what is meant by curing of stones, what is meant by dressing of stones, and finally we see about artificial stones. Let me start with the introduction. In any building structures, these structures are composed of different types of materials. So these materials are either called as a building materials or materials of construction. It is very essential for a builder or maybe an architecture or engineer or contractor to become conversant thoroughly with these building materials. So the knowledge of these different types of materials, their properties, and the use for different purposes provides an important tool in the hands of the builders in achieving economy in material cost. So these building material cost 30 to 50% of the total cost of construction. So in addition to material economy, the correct use of materials results in better structural strength, functional efficiency, and aesthetic appearances. So there are different types of materials are available, mainly in masonry materials. One is stone masonry, brick masonry, and cement mortar masonries. So today we are going to see about the stone masonry in this video. So building stones. Everywhere we can see the stones in the earth surface. Where we are getting these stones are derived from the rock, which are portions of the earth crust. So let me start with the classification of rocks. Classification of rocks. The rocks are classified into three major types. One is geological classification, one is physical classification, another one is chemical classification. Under geological classifications, the rocks are divided into three major groups, that is igneous rock, sedimentary rocks, and metamorphic rocks. So under physical classification, we have stratified rocks, unstratified rocks, and foliated rocks. In chemical classification also, rocks again subdivided into three types. One is siliceous rock, argillaceous rocks, and calcareous rock. We see these rocks one by one. Let's start with the sedimentary rocks. The sedimentary rock is one of the three main rock groups along with igneous and metamorphic rock. The sedimentary rock covers 75% of the earth's surface. The sedimentary rocks are formed due to the action of weathering. While weathering, the primary rocks are broken up and gradually deposited for ages at bottom of river or sea. Some examples like chalk, limestone, sandstone, clay, and shale are the general examples of the sedimentary rocks. Second is igneous rock. This igneous rock is also called as magmatic rocks. Why? Because these igneous rocks are formed by magma or lava during the volcanic eruption, and it is cooled and solidified on the surface of the earth. So these molten minerals after solidification gives the igneous rock. Some of the examples like granite, ballast, dolerite are the few examples of the igneous rock. Last is a metamorphic rock. These metamorphic rocks arises from the transformation of existing rock type in a process called metamorphism. The metamorphism means change in form. So the original rock is subjected to heat and pressure, causing profound physical or chemical changes. So due to these physical and chemical changes and the change in form will give us the metamorphic rocks. Some of the best examples of metamorphic rocks are quartzite, schist, slate, marbles are some of the examples. Stratified rocks. Stratified rocks consist of different layers in its structures, and these layers are separated by the planes of stratification. These planes are also called cleavage planes or bedding planes. So these rocks can easily split along these bedding planes. Most of the sedimentary rocks such as sandstone, limestone, shale are the best examples of stratified rocks. Unstratified rocks. So the unstratified rocks have the structure of crystalline granular or compact granular. So they possess a similar kind of structure throughout their whole body. Most of the igneous rock and some sedimentary rocks affected by earth movement come under unstratified rocks. Examples are marble, granite are the best examples for unstratified rocks. Foliated rock. This foliated rock proposes a layer of or layered or banded structure which is obtained by exposure of pressure and heat. Unlike the stratified rocks, these rocks can split up in a certain direction only. Most of the metamorphic rocks formed by metamorphism come under foliated rocks. Best examples are schist, slate, gneiss are the best examples for the foliated siliceous rock. So the rock which contains silica in predominant amount are called as siliceous rock. So presence of large amount of free silica makes them harder and durable. And it also provides strong resistance to weathering also. So the best examples of siliceous rocks are granite, quartzite, strut are the best examples of the siliceous rock. Next is argillaceous rock. The word argil means clay. So hence the rocks in which clay content is predominant are called argillaceous rock. So these rocks are soft in nature and with the presence of water they can be crumbled easily. In the dry state, these rocks can be crushed easily because of their brittleness. Shale, slate, laterite are some of the examples of argillaceous rocks. Calcareous rock. The rock in which calcium carbonate is the major ingredient are known as calcareous rocks. So these are generally hard, but the durability is dependent on surrounding constituents which may react with the calcium and affect the durability of rock. Marble, limestone, dolomite, etc. are some of the examples of calcium predominant rocks. These are the images for igneous rock, metamorphic rock, sedimentary rock, so how the stratified rocks will occur or how it is a foliated rocks will looks like. So this diagram shows the types of different types of igneous rock: anthracite, basalt, diorite, most importantly granite. Then in under metamorphic rock we have slate, quartzite, marble, schist, gneiss. These are the some of the examples of metamorphic rock. This is how the rocks will be in nature. So in sedimentary rock we have limestone, sandstone, shale, rock salt. So this is how the stratified rocks will look like, layer by layer, different layer by layer. So this is foliated rocks. This is unfoliated rocks. Okay. So what are the requirement of good building stone? First is crushing strength. So for a good building stone, crushing strength should be greater than 1000 kg per centimeter square. Second, its appearances. So the good building stone should have a uniform color and free from clay holes, and it should have capable of preserving the color for long time. Next is durability. A good building stone should be durable. Factors like cold and heat, alternative of wet and dry, dissolved gases in rain, high wind velocity, these are all the factors it will affect the durability. So a good stone will have capability to withstand these type of effects, and it should have, so that it will have a good durable. Next is a fracture. So fracture is nothing but a crack in a material. So here it is crack means, so stones are we are getting from the rock. So we have to break down the rocks. So we have to crack the rock to get these stones. So that crack part, that fracture part should be sharp, even and clear. It should not be uneven. It should be even, sharp and clear edges. Next is hardness. So the hardness in the stone, if it is greater than 17, it is treated as a hard, and it will be used in roadworks. Between 14 to 17, it is medium hardness. Less than 14, it is a poor hardness. So less than 14, we won't use in the building structures. Okay. Then percentage of wear. So for a good building stone, the percentage of wear should be equal to or less than 3%. And it should have the resistance of fire. Stones should be fireproof. In argillaceous stone, resist fire quite well, other than siliceous rock or calcareous stones. And the specific gravity of the stone should be greater than 8.7. And if you put the stone in the water for 24 hours, the water absorbed by the stone should not exceed 0.6 of its own weight. Next is, a good building stone should have compacted fine crystalline structure, and it should be free from cavities, cracks, or patches of stuff or loose materials. Seasoning. Stones should be well seasoned before putting into use. A period of about 6 to 12 months is considered to be sufficient for proper seasoning. Toughness index. So to identify the toughness index, we perform impact test on these stones. By the values of the impact test, we will say whether this rock is tough enough to hold the structure. If it is less than 13, we say it is not tough. Between 13 to 19, we will say moderate tough. If it is the impact value is greater than 19, we will say the stone have high tough value. Next heading is dressing of stones. So this dressing of stones is required because the stones we are getting from the quarry, it does not have a exact dimension, required dimension, or the exact required finishes. So the dressing of stone is the process of working on the quarried stone to make them in the required shape and the required sizes for the usage. There are different types of dressings. First is hammer dressing. So in this hammer dressing, large portion of the stones are broke off, and the stone is shaped somewhat flat but rough due to the hammer markings. See here, some of the portions are broken off, and we are making this stone in somewhat shapes, but the shape is a rough one. So in next one is a pitch face dressing. So in a pitch face dressing, what we are going to do is only the edges of the stone blocks are made level with the help of hammer, not the entire face, only the edge of the stone are made level with the help of hammer. So next one is the rough tooling. So in this rough tooling, the edges are first squared by using a chisel or hammer, then a series of grooves of available width are developed over the surface of these stones. So these are these various series of grooves available. And once the dressing of the stones are over, we will get a stone like this on a various grooves. The next heading is quarrying of stones. So the process of quarrying is known as how we are getting the stone from the natural rock bed or layer. So how we are going to extract these suitable stones from their natural rock beds or layer is commonly called as quarrying of stones. There are various methods of quarrying: excavating, wedging, heating, or blasting. So this one is called for wedging purpose. So these are the tools we are using for the wedging, and this one is a for blast. So we will see one by one. In the excavating, stones buried in earth or under loose overburden are excavated with the help of pickaxes, crowbars, chisels, hammers, etc. So this method is employed when the quarries consist of small and soft pieces. Next is heating. It is the most suitable for quarrying small, thin and natural blocks of stones from rocks such as granite and gneiss. So how we are going to do this heating process is a heap of fuel is filled and fired on the surface of rock in small areas. So what happens when these rocks are heated? The two consecutive layers of the rock separated because of uneven expansion of the two layers. So the loosened rock portions are broken into pieces of the desired size and are removed with the help of pickaxes and crowbars. So the stones blocks obtained from the heating process are very suitable for coarse rubble masonry. Okay. Next is blasting. So blasting means it is an exploding something. So explosives such as blasting powder, blasting cotton, dynamite or cordite are used. The operation in the blasting involved boring, charging, tamping and firing. So first we have to bore a drill hole to inject the gunpowder, and we have to charge that gunpowder and we can fire it. So once the rocks are blasted, the big rock will be blasted into a small stones. Next is wedging. So this method of coring is suitable for costly, soft and stratified rocks such as sandstone, limestone, laterite, marble and slate. So what is the process of wedging is about we have to dig 10 to 15 centimeter deep holes at around 10 centimeter spacing are made vertically in the rock. So then once the deep holes are digged, we have to insert steel pins and wedges of plugs and feathers. So once it is inserted, we have to struck these plugs simultaneously with the sledgehammer. So once it is continuously struck with the sledgehammer, the rock slab splits along the line of the least resistance through the hole. This is the process of wedging. The final topic is artificial or cast stones. When the natural stones are not available at reasonable cost, we go with the artificial or cast stones. These artificial stones are made with cement and natural aggregates of the crushed stone and sand with the desired surface finish. We can also add suitable color pigments to it. So these artificial stones can be molded into the most intricate forms, and it can cast into any size. We can reinforce them to have a higher strength also. These artificial stones are suitable for face works since its grooves and rivets can be cast easily, and it is also more economical too. So let's see some of the available cast stones in the market. First is concrete block. It can be cast at site in the construction of piers, or cast in molds for steps, window sills, etc. And the second one is ramson stone. These ramson stones are prepared by mixing soda silicate with cement. These ramson stone can also be provided as a decorative flooring. These ramson stone is also called as chemical stones, and it is having a compressive strength of about 32 Newton per mm square. Third one is imperial stone. These imperial stones are prepared by mixing finely crushed granite with Portland cement. So once the mixture is prepared, the mix is molded and steamed for 24 hours. Once the curing is over, the cured blocks are immersed in silicate tanks for 3 days before it going to use. Next is artificial marble. These artificial marbles can be either prepared in precast or cast in soot. These artificial marbles are made from Portland gypsum cement and sand. These artificial marbles are used for external works only. Next is Victoria stones. These Victoria stones are made in granite pieces. These granite pieces with the surface hardened by keeping immersed in soda silicate for about 2 months before it going to use. Next is bituminous stone. The granite or diorite are impregnated with prepared or refined tar to form bituminous stone. These bituminous stones are used for providing noise, wear and dust resistant stone surface. Next is garlic stone. These garlic stones are produced by molding a mixture of iron slag and Portland cement. These garlic stones are used for flag stones, suffix drains, etc. We can use these garlic stones. The advantages of artificial stone. In the artificial stone, we can kept cavities to provide the pipes or electric wires in the building. So in the artificial stone, we can keep a grooves in while in the casting itself, and it is very useful for fixing the various fittings. And these artificial stones can cast on any desired shape, and it can be made in a single piece also, and it can be more stronger than natural stones. It is very cheap and economical too, and it is more durable than the natural stone. So in this video we covered what are the classification of rocks, that is geological classification, physical classification, and chemical classification of the rocks. Then we saw about the what are the requirements of good building stone. Then we saw what is the dressing of stone, and we saw the quarrying of stone, and finally we saw the artificial or cast stones. So these are the some references you have to you can follow. Thank you.